All right, welcome to the explainer. So you've probably had this happen. You ask an AI a question, and it gives you this answer that sounds super smart, super confident, but it's just completely wrong. That right there is what we call a hallucination. And today, we're going to dig into a really cool paper that explains why these AIs sometimes, well, bluff. It all kicks off with one simple wrong answer.
Okay, let's just jump right in with a perfect example of this. And it comes straight from the research paper we're looking at. The author actually asked a few different AIs about his own PhD dissertation. I mean, talk about a trick question, right? And what you see here is ChatGPT's answer. It sounds plausible. It's in the right field, has the right kind of academic-sounding title, but it is just dead wrong. Even the year is off. And it wasn't just ChatGPT. Other models did the same thing. This is the heart of the problem, you know? The AI makes up an answer that sounds totally reasonable, but it's just fiction.
So to really wrap our heads around this, the paper gives us this great analogy that we're going to stick with. Instead of thinking of an AI as some kind of all-knowing oracle, picture it as a really, really smart student who's taking a super hard exam. And what's that student's only goal? To get the highest score. That's it. And think about it. When you're in a tough exam and you don't know the answer, what's the best strategy? A lot of the time, it's to make a really good, educated guess.
So where do these mistakes, these hallucinations, even begin? I mean, how did they get into the system in the first place? Well, to find the root cause, we've got to go all the way back to square one, the pre-training phase. You can think of this as the AI study hall. It's where it just reads and reads and reads, basically the entire internet, to learn the patterns of how we talk and write.
Now that brings up a really good question, one you're probably thinking right now. If we feed the AI a diet of nothing but perfect, error-free facts, shouldn't it just spit out perfect factual answers? It seems logical, right? But what this paper argues is that even with the best study materials in the world, the way these models learn, it's all based on statistics and probability, pretty much guarantees that they're going to make mistakes. It's baked right into the process.
Okay, so to really break this down and show us how it works, the researchers did something pretty clever. They took this really complicated task, generating a whole block of text, and they boiled it down to something way, way simpler. A basic yes or no question. They call it the Is It Valid classification problem, or IIV. Basically, instead of asking the AI to come up with the right answer, you just give it a statement and ask, hey, is this statement valid? Yes or no. That's it. Super simple.
All right, this is where it gets really interesting. And we can visualize this using the ideas from Figure 1 in the paper. There are basically three ways this simple yes-no classification can go wrong. First, you've got separable data. Think of this like spelling. There are clear rules, right? I before E except after C. It's a pattern a model can learn pretty easily. Second, you might just have a poor model. This is like using the wrong tool for the job. You wouldn't use a hammer to drive a screw. Same idea here. Maybe the model just isn't built to understand something like counting letters in a word. But the third one, this is the big one for hallucinations, no pattern. Think about birthdays or historical dates. There's no deep logical pattern to learn. It's just a random fact. You either know it or you don't. And that's where things get tricky for a statistical model.
Okay, and here is the absolute kicker. The paper draws a direct mathematical line between these two things. It turns out a model's error rate when it's generating an answer is about twice as high as its error rate on that simple yes or no task. Let that sink in. If the AI has a hard time just spotting a mistake, it's going to be at least twice as bad at not making that mistake itself. This is the statistical seed of every single hallucination.
All right, so that was the study phase. Now let's move into the exam room. This is the post-training phase. We've just seen how the potential for errors gets baked in while the AI is studying. Now we're going to see how the test itself, the way we evaluate these models, actually pushes them to guess and hallucinate instead of just saying, you know what, I don't know.
So what's the problem here? It all comes down to how we grade these AI students. Almost all of the big AI tests or benchmarks use something called binary 0-1 scoring. And it's exactly what it sounds like. It's a multiple choice test. You get 1 point if you're right and 0 if you're wrong. But, and this is the key part, you also get 0 points if you just say, I don't know. So if you're that student trying to maximize your score, there's absolutely 0 penalty for taking a wild guess. Why not go for it?
And this is just fascinating. This visualization, which is based on Figure 2 from the paper, shows exactly what happens. Okay, look at the chart on the left. This is the model before all that test prep. See how the bars kind of hug that dashed line? That means its confidence actually matches its accuracy. It's well calibrated. It knows what it knows. But now look at the chart on the right. This is the model after it's been trained to get the highest possible score on those tests. It's way, way more confident. Just look how tall that bar on the far right is. But it's no longer calibrated. The curve is pulled away from that line of reality. The takeaway here is so important. We've literally trained it to be a confident guesser, not an honest student.
So, let's recap. The studying part bakes in the potential for errors, and the testing part actually rewards the AI for making those errors. So, what do we do about it? Well, the paper's solution isn't to create more complicated tests. It's much simpler. It's about changing the rules of the game.
And you don't have to take my word for it. Just look at the evidence. This table, pulled from the paper, lists some of the biggest, most important benchmarks that we use to decide which AI is best. Just scan down that binary grading column. What do you see? Yes, yes, yes. Pretty much all of them use this system. They all effectively punish a model for having the humility to say, I don't know. The paper calls this an epidemic of penalizing uncertainty, and that just nails it.
So, what's the fix? It's actually really simple, but it's also kind of genius. We just change the scoring. On the left is how we do it now. On the right is the proposal. A right answer still gets you 1 point. Saying I don't know is still a safe bet 0. But, and here's the game changer, a wrong answer, a hallucination, now costs you. You get -2 points. All of a sudden, guessing is a really bad idea, and saying I don't know becomes the smart, rational play when you're not sure.
This means you have to be totally straight with the AI, just like you would with a student walking into an exam. You spell out the rules right in the prompt. You say, hey, answer this only if you're sure, because if you're wrong, it's going to cost you. This gives the model a clear reason to say I don't know whenever its internal confidence drops below a certain point. The goal here isn't just to get the AI to spit out a confidence score, like I'm 70% sure. The goal is to make it behave in a calibrated way. It's about actions, not just words.
Okay, let's put it all together. What's the big conclusion here? It's actually pretty straightforward. Hallucinations aren't some weird, mysterious bug. It's not a ghost in the machine, and it's definitely not the AI trying to lie to us. No, they are the perfectly predictable, perfectly logical result of the very system we've built to train and test them. We're getting exactly what we're grading for.
And speaking of things you can be confident about, if you want more explainers that are guaranteed to never hallucinate, well, you know what to do. Hit that subscribe button on the Vibe Doc channel. We are 100% confident that you won't regret it, probably. And this whole thing leaves us with a really big question to chew on. If we start grading these AIs on their honesty, not just their accuracy, what kind of intelligence are we actually building? Are we just making them a little less wrong? Or are we maybe creating something fundamentally different, something more trustworthy, and in the end, a whole lot more useful?